Game theory using mixed strategy. First and foremost, we need to check closely whether a pure strategy can be used in this case or a mixed strategy. So first and foremost, let's check whether a pure strategy can be used or not. So throughout the entire row, I'm going to find my maximum. So I'll first find my minimax, which is -7, -6 and -7. Then I'll select the maximum number, which is -6. So throughout the entire column, I'm going to find my minimax. So the maximum number first, 9, 8 and 4. Then the smallest number is 4. So if you check closely, you find out that there is no what? There is no saddle point, because the minimax does not equate the maximum. Okay, we have 4 and -6, which means a pure strategy cannot be used in this case. Then I will proceed using my mix strategy. So I'm going to use the dominant rule for my mix strategy. So the dominant rule is all about reducing the matrix as much as possible. Then I'm going to start with my rule reduction first. I'm trying to reduce the matrix as much as possible, and I'm starting with my rule reduction. So 9 plus 8 minus 7 is 10. 3 minus 6 plus 4 is 1. 6 plus 7 minus 7 is 6. So I'll now select the smallest number, which is 1. Then check through that rule, compare it with the first row and the third row. Now 3 is lesser than 9, fine. -6 is lesser than 8, fine. 4 is greater than -7, which means the second row does not dominate the first row. So I'm going to compare the second row and the third row as well. 3 is lesser than 6, -6 is lesser than 7, fine, but 4 is greater than -7, which means the second row does not dominate the third row as well. So I'm going to select the least number from after 1, which is 6, which is the third row, then compare it with the first row and second row. 6 is lesser than 9, fine. 7 is lesser than 8, fine. -7 equates -7, which means the third row dominates the first row. So I'm going to cancel out the third row entirely because it has already been dominated by the first row. Then the last one to 10, 9 is greater than 3. So which means the first row does not dominate the second row. So I cannot reduce the matrix row wisely more than that. So then I cannot reduce the matrix row wisely more than that. Then I'll have to proceed to my column reduction. So this time around, I'm checking for the highest number that dominates. So 9 plus 3 is 12. 3 minus 6 is 2. -7 plus 4 is -3. So I'm going to select the highest number this time around, which is 12. Then through that column, I'm going to compare it with the second column and the third column. 9 is greater than 8, fine. 3 is greater than -6, fine. So which means the first column dominates the second column. So the second highest number is 2. Then I'm going to compare it with my third column. 8 is greater than -7, but -6 is lesser than 4, which means the second column does not dominate the third column, and 3 as well. So which means the first column dominates the second column, but the third column does not dominate the second column. So I'm going to bring it out entirely. 8 minus 7 minus 6 and 4. Then I'm going to introduce my x, 1 minus x, y, 1 minus y. So what this means is that let player A play B1 as x and B2 as 1 minus x, and let player B the column multiplied by the rows. 8 multiplied by x is 8x plus -6 multiplied by 1 minus x equals to -7 multiplied by x is -7x plus 4 multiplied by 1 minus x. So I'm solving for x first. 8x plus times minus is minus, which is minus 6 multiplied by 1 is minus 6. Minus 6 multiplied by minus x is plus 6x equals to minus 7x plus 4 times 1 is 4 plus 4 times minus x is minus 4x. So 8x plus 6x minus 6 equals to minus 7x minus 4x plus 4. 8x plus 6x is 14x minus 6 equals to minus 7x minus 4x is minus 11x plus 4. Now I can now collect the like time. So 14x minus 11 is coming over plus 11x equals to minus 6 is coming, which is 6 plus 4. So 11x plus 14x is 25x equals to 6 plus 6 is 10, which means our x is 10 divided by 25. So 5 can divide 10 to it will be 2, and 5 in 25 is 5. So our x is 2 over 5, which means our 1 minus x will be 3 over 5. What can I add to 2 to be 5, which is 3? That's why I got my 3 over 5. So now I'm going to input it back into the formula, but 2 divided by 5 is still 0.4, and 3 divided by 5 is still 0.6. So I'm going to input it back into the formula. 0.4 minus plus or minus is still the same, 0.6 equals to minus 7, 0.4 plus 4 open the bracket of 0.6. 8 multiplied by 0.4 is 3.2 plus 6 multiplied by 0. Plus times minus is minus. Minus 6 multiplied by 0.6 is minus 3.6 equals to minus 7 multiplied by 0.4 is minus 2.8 plus 4 multiplied by 0.6 is plus 2.4. 3.2 minus 3.6 is minus 0.4, and minus 2.8 plus 2.4 is 0.4, which is equals to 0.
8 multiplied by y, so it's 8y plus minus 7 multiplied by 1 minus y equals to minus 6 y plus 4 open the bracket of 1 minus y. So 8y plus times minus is minus. Minus 7 times 1 is minus 7. Minus 7 times minus y is plus 7y equals to minus 6y plus 4 times 1 is 4 plus 4 times minus y is minus 4y. So this will be 8y plus 7y minus 7 equals to minus 6y minus 4y plus 4. Then I can now collect the like time. 8y plus 7y plus 6y plus 4y equals to minus 7 is coming here, 7 plus 4. So 8y plus 7y plus 6y plus 4y is 25y equals to 7 plus 4 is 11. So our y is now 11 divided by 25. Okay, is 11 divided by 25. What can I add to 11 to be 25, which is 14, which means our 1 minus y is 14 divided by 25. So 11 divided by 25 is 0.44. 14 divided by 25 is 0.56. So I'm going to input this back into the formula. So 8 open bracket of 0.44 minus 7 open bracket of 0.56 equals to minus 6 open bracket of 0.44 plus 4 open bracket of 0.56. Okay, 8 multiplied by 0.44 is 3.52 minus 7 multiplied by 0.56 is minus 3.92 minus 7 multiplied by 0.44 minus 2.64 minus 4 multiplied by 0.56 plus 2.24. So 3.52 minus 3.92 is minus 0.4 minus 2.64 plus 2.24 is minus 0.4. So let me collect the like time. So this will be 0.4 minus 0.4, which is equals to 0. Okay, now if you check closely, you find out that this answer equates the previous answer that we got for our x, which means the value of the game is minus 4 minus 0.4.